All right, so number one. So bear with me because I'm going to be using a mouse to try and write here. So the key to this is that you've got a 2 to 3, right? You have a 2 to 3 ratio from quadrilateral ABCD to quadrilateral EFGH. Now I'm going to go ahead and write that over here, 2 to 3. Okay. Now we're going to use that. You're always going to use your scale factor when you're solving for things like this. So I'm going to say 2 to 3 equals, I need another fraction over here, right? Now I'm going to need a variable because I'm solving for a missing length. That missing length is going to be the length EH. So I'm going to make that X. Now where do I put that X? Well, let's take a look. It says ABCD to EFGH is 2 to 3. That means that because it's this to this, that's that to that. That means that we got the ABCD is the smaller, okay? And EFGH is the bigger of the two, right? Well, EH is a side in the bigger one. Well, 2 to 3, I got to match the EH side X up with the 3. So that goes in the bottom of our fraction, okay? So now what we need is we need the corresponding side that goes with EH. Well, EH is the first and last letters of our quadrilateral name. So the first and last of this first one is A and D. Well, there's our AD length, 15. That's the small corresponding length. So that goes up here. Okay. So to get my final, here I got to cross multiply. All right. 2 times X is 2X. 3 times 15 is 45. All right. Divide both sides by 2. That's 22.5. And that would be our answer. Okay. Because that's what we found out there. We made X our EH length. So 2 to 3. So we're comparing the two lengths here, AD to EH. And the AD length is 15. We don't know the EH length, but we can cross multiply and solve for it. All right.
Thank you.
Yep. Let's see here. Let's take a look at another one. I know which one is causing people a lot of problems. Let's go to number. Yeah. So this is the one where you're dilating about a point that's not the center. Okay. So typically when it says dilate ABC by a scale factor of 3, you dilate it from the center, and then you just look at these coordinates like -2, -1, and you'd multiply the coordinates by 3, which would be -6, -3, all right, which would dilate point C way down here. Now, that's correct if you're dilating from the origin, 0, 0. But in this case, we're dilating from D, okay? So in this, what we're doing here, because we're dilating from D, what I'm going to do is I'm going to draw a new pair of X and Y axes, okay? Now, just for the dilation, okay, just for the dilation, we are going to use point D as the origin, right? And we have new points here for A, B, and C. Like A is at -1, 3, okay? -1, oh, this is going to be hard to do. -1, comma, 3. Okay, that's point A. Now we know that this maps to, we're going to multiply these by 3 because it's a scale factor of 3. So A prime is at, multiplying by 3, -3, 9. Okay, so that would be my dilated point along here. Now when I mark -3, 9, that's 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right here. Okay, now the point that I just put here, That point with the red axis is at negative 3, 9. Now that's not the actual point of dilation from point D. The actual point would be is if I'm starting at 0, 0 on my original axis, that'd be at negative 8, 7. Okay, that'd be at negative 8, 7. So if I were to go back to my click on my polygon thing here and click on the polygon, my A prime would actually go there, which is at negative 3, 9 if I'm using the red, but if I'm using the regular axes, that's at negative 8, 7. Okay, so that's where A would go. Now B is at 0, 1 on the red axis. So if I go multiply both by 3, that's at 0, 3. So B prime is at 0, 3 on the red. Now on the regular axis, that's at negative 5, 1. Now C is at 1, 2, 3, 1. All right, 3, 1. So if I multiply by 3, that'd go to 9, 3. Well, let's go ahead and count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. All right. Now I'm going to go ahead and clear out all the drawings. Now this makes sense. If I'm dilating from D, right, A prime is now 3 times as far away from D as A was. B prime is 3 times as far away as B is. And C prime is 3 times as far away than C is, all to point D. All right. So it's getting bigger from D. All right. That was definitely one that some people were struggling with. This is another one that people had a little hard time with. So it says, which of the following best describes the transformation of triangle ABC to A prime, B prime, C prime, and then to triangle A double prime, B double prime, C double prime. Now, the single prime ones are actually these up here. So our original triangle is in the top right quadrant. Now, it's not a reflection because it doesn't stay the same orientation. This is going to be a rotation. So there's 2 rotation ones here. We got B and C. That's the first thing. First, a rotation. Well, let's see what we're going to do after our rotation. Right? It's either going to be translate down 4 units or reflect over the x-axis. Now, translating it down 4 units would work. It would keep the triangle on top of this triangle. But you see the points are off. See how A prime is right here? If I just translate it down 4 units, 1, 2, 3, 4, this should be A double prime, but it's C double prime. All right, so that's not correct. So in this case, it actually is going to need to be reflected over the x-axis. That way the C, when it gets reflected, stays on top of C prime. And when A prime gets reflected, it goes to A double prime. Okay, so that's where we'll get our answer for number 13 here. Which of the following is the equation for the line of reflection shown in the transformation below? So this is confusing to everybody, to be honest with you. It doesn't make sense. Horizontal lines should be x equals because x is the horizontal axis, and that's not right. Horizontal lines are actually y equals, and their line of reflection here is actually going to be a horizontal line because the purple and the red reflect on top of each other this direction. So that means our line of reflection needs to be here somewhere. And our correct answer is going to be y equals negative 2, right? And the reason it's y equals negative 2 is because every point on that line has a y value of negative 2. Okay. The way we can double check, if I take this bottom left point in the red triangle and the top left point in the purple, they are 1, 2, 3, 4, 5, 6 units apart. So halfway in between is where the line of reflection will be. That's 3 units. 1, 2, 3. That's at negative 2. And it'd be y equals negative 2. Okay. That's where we get our answer for 12. All right. So rotations. Actually, yeah, we'll do number 10 and 11. So number 10's a 90 degrees clockwise rotation. If you guys remember, and you guys can use this on your test, week 16, the very first thing, transformations cheat sheet, rules cheat sheet, okay? So rotations are at the bottom. if I look, I see that there is a 90-degree clockwise. So clockwise 90. It says x comma y maps to y comma negative x. Right? X comma y. So let's x comma y maps to y comma negative x. All right. So what that means is if I have a point, let's say A is at 2, 6, right? Well, 2, 6, that's going to map to, so the y stays the same, 6, but the x becomes the opposite. So that 2 becomes a negative 2. So if I look and see here, all right, 6, negative 2, 6, negative 2, my new point, or A prime, is going to be here. Okay. Let's go ahead and let's get the polygon up here. So A prime is going to be at 6, negative 2. Well, let's look at B. B is at 1, 1. Well, 1, 1, the y stays the same, so that's going to be 1, negative 1. So B prime goes to 1, negative 1. C is at 3, 2. That's going to become 2, comma, negative 3 because the x becomes opposite. So the C goes to 2, negative 3. This purple triangle is the rotated image of the gray one, 90 degrees clockwise. Okay. Taking a look at number 12, sorry, number 10. All right, this one's rotating 180 degrees counterclockwise, which is this direction. And the nice thing with 180, it doesn't matter if it's clockwise or counterclockwise, it's going to be the same. So the mapping rule for this one is x comma y maps to negative x comma negative y. All right. It just completely 180 degrees counterclockwise or clockwise. It's x comma y maps to negative x comma negative y. All right. Pretty straightforward rule here. So B is at, here, I'm going to pull my polygon up so we can do it as we go. B is at negative 1, 0. So again, they stay x and y, but they're opposite. So that becomes positive 1, 0. So B goes to here. B prime goes there. A is at negative 2, 2. So that becomes positive 2, negative 2. That goes there. C is at negative 1, 2. That goes to 1, negative 2. So 1, negative 2. And D is at 0, 6. So that goes to 0, negative 6. All right, this has now been rotated 180 degrees. We went counterclockwise this way, but they're the same either way. Okay. All right, I think a lot of the others are pretty straightforward. Are there any others that you guys can think of that you have any questions on?